Diane? Diane, I'm listening. Anyone who can hear what Diane is saying can please pass the message. If you can hear what Diane is trying to share with us, please share the message.
Morning,
Because I
sir.
cannot.
I was reading can you record.
Oh, okay. No, thank you very much for that. Last week we introduced this chapter, which is the analysis of covariance, and I indicated that is the combination of two models, the simple linear regression model together with the CRD method. Since we don't have issues with the CRD method, we're just going to go to that CRD problem and we add the covariate of x. So any value of y will be having what? I will be having a value of x. So if we have 10 values of y, we'll have 10 values of x. So the problem can also be solved as a what? As a simple linear regression problem. And I indicated last week that those who didn't do, for those who didn't do, someone's mic is on. Someone's mic is on. Not sure if you're aware. The leader, please mute your mic. Uh, Last week I said for those who were not with us in the first semester, or you didn't get it when we were doing the simple applied linear regression, feel free to come and consult, because the background of simple linear regression is very, very important in this case. So you must know how to find the sum of squares. These ones here. Before we can go back to that problem, I know we have a problem at the end that we need to discuss. We discussed these expressions, right? These formulas here. We discussed all of them, and we also made correction on what? On this one. Those who attended our class, we made correction on those ones. So I asked you to go and find these summations, the answers for all these things here before we can move. So at first, before we knock off last week, you managed to find the sum of yij xij squared. You managed to find y dot dot. You managed to find x dot dot, right? Same applies to these ones. So can you please give me the answers? Because I gave you a task to go and find the summaries of all these things. So I don't expect leaders to say, how did you find that? You must first explain what you are having from your side if you are not agreeing with what is being presented here. So can I suggest someone to help us with the values? But not Simanga, because Simanga, I was here, I was with him, he came, I saw what he did. So I want a different person to share with us what the solutions for all this based on the last week example. Can I get a volunteer, please? Someone who can give me this. Yes, Deborah. Deborah.
Hello, sir.
Yes.
For SSYY is negative
SS
YY.
SSYY.
Yeah.
Remember, these are what? These are sum of squares. So the only part where we can get a negative is on this one. the one, this one, the one that I said to put a dot. Let me put a red dot. We can get a negative on this one and also on this one. Otherwise, the other ones cannot be negative. The other ones were expecting positive. It's for which one? Are you sure it's for SSYY, not SSXY?
For SSXY is 161,933.
160.
1,
Yes.
933.
Okay, so let's confirm the value. Leaders, what did you get?
282.6.
And let me write what is there is for SSXY. Chris?
Yes.
You're saying is what?
282.6.
282. Point what?
0.6.
0.6. Guys, we have a value on the left, or let me do it like this. Let me do it like this to make life easy. I'm coming, guys. Please be patient with us. Be patient with us. I want to do something here. You're saying 2, 8. You said what, my brother, Chris?
282.6.
Yes.
Yes.
So the question is, which answer is correct, the blue or red? Which answer is correct between blue and red?
The blue one.
The blue one. So can someone Tebuo, you have the calculations right. What is your x? Please let's help her. What is your first part? This one. We want to check where did you get this wrong. What is this part, Tebuo? Listen to Tebuo, guys. If it is right, please.
14835.
Yes. What about y dot dot? This one.
608.
Is it correct, guys? He's saying 608. What about x dot dot?
603.
They're saying 603, Tebuo.
Okay.
And then x dot dot. What are you having, Tebuo?
362.
362. So your mistake is when you wrote what? 3. You said 6 what? 683.
608.
Yeah, that is the problem. So your mistake is there. The other values leaders are agreeing, except the 608 is supposed to be 603.
Okay.
Thank you very much. So you know your mistake, Table, right? So now the one
Yes.
from the way not correct. Thank you, Table. Can we continue? SYY. Can someone help us now to not Manga, Rasibuta? Yes, I'm listening.
Yeah, SYY is the 346,4.
346.4. And do you agree, guys? Anyone who's having a different answer?
Yes. Agree.
Who's that? Chris?
Agree.
Okay. What are you having, Chris?
The same one.
Oh, it's fine. So this one, 6. Someone is saying 616.4. Who's this one? Mamba. Hey, I'm failing to pronounce your surname, leadership. Tepang. Tepang. Tepang, unmute your mic, please. Let's move. We want to help you because people are saying this is the correct one. We want to check where did you get this wrong. Tepang.
Sir.
What is your Yij squared? The first part.
24857.
Do you agree, guys? She's saying 24. You're saying it's what?
24857.
They're saying it's not correct. What is the correct value, guys?
24587.
Please, I'm the only one writing, guys. Please, no one should supposed to write on my board, please. 24587. Do you see the right value, my sister?
Yes.
What about y dot dot squared? When you square all your, you first sum the values and square them. What is the value? Now the second part. Now I'm referring to this part here. What are you having? Y dot dot. What is your y dot dot?
It's 603 squared.
Thank you. That one is correct. So your mistake is only on the first part, right?
Yeah.
Can we move?
Yes.
Thank you very much. Let's move to SSXX.
Yeah,
Manga, now
it's,
you rested. It's enough. If you want to help us, you can help us. Yes, who's talking?
yeah, it's still me, sir.
Okay, let's go.
It's 261,73.
261.73. Anyone who's having a different answer? Please feel free, guys.
73333.
So I just have to add 3333. Anyone who's having a different answer? So we're moving with this one. Thank you. Let's move. EXX.
Is
EXX, guys.
195,6.
The same guy.
Yeah,
It's what?
195,6.
195.6. So are we, anyone getting a different answer? EXX? Feel free, guys. We're here to learn. Everyone is happy with the value. EXY, with that correction from the formula first. You first correct the formula here. This is corrected, remember? You know what to put here. So I said
Yeah,
you put that here. Yes, with that correction. What is the value?
it's 186,6.
186.6. So those who don't have these values, please write them somewhere because we'll need them now when we want to construct. Candy, are you having a different answer?
Can they please explain how they got it? I'm failing to calculate it.
Okay, what do we have? You don't even have the answer.
Yeah, that's
Candy?
the only one that I was failing to calculate. Yes.
So I assume, Candy, the first part you have it because it's the same part. The first part is the same as XY, right? This part, Candy.
Mm.
So this part we have it, right?
Mm.
Yes. So the only part that you don't have is the second part, right? Is this one here.
Yeah.
So what you do, let me just save time. What you do, Candy, you have values from those track 1, track 2, or track 2 and track 3, isn't it?
Mm.
With the values of X and the values of Y, isn't it? From each track, XY, XY, and XY. Isn't it, Candy?
Yes.
This is what we're having, right? From the 3 tracks. So what you do now, for you to find that part, for you to find this part here, you what? You multiply. Oh, I'm looking for this draw. Since now you have the sum, right? You have the sum of these values, isn't it, Kent? You have the sum here from each and every treatment, right?
Yes.
So you take this, the sum of the sum of X multiplied by the sum of y. Do you get it, Candy? Plus, now we're
Yes.
applying the summation now. Plus the sum of from the second treatment, multiply it by what? The sum of the y from that treatment. And then now we just use the summation plus.
Okay.
Do you understand? The sum multiplied
Yes.
by what? So are we cool now? Are we okay, Candy?
Yes.
Can we move? Thank you.
Yes.
So the last one is EYY. And please give us EYY. Rasibuta, can you please close by giving
Yeah.
us the EYY?
EYY is
206.
206.
Is 206.
Yeah.
So now, guys, you have this summary, and I explained that this one here, this SSYY is the same as SSTO, right? It's the same as SSTO. So you have your SSTO there is what? 346.4. Can someone help us with SSE? Because this is the only thing that we want. SSE from CRD, and then SST from CRD. Only give me these two. What do I mean by from CRD? So it means ignoring the values of X. Can you please give me SSE and SST? Because already now we have what? SSTO. Can someone help us with the SSE and SS treatment from that problem? Do you want me to project the data set? Do you want me to help you with the data set so that you can calculate? Find SSE. This is the same as me saying ignore the covariate X, find the what? Find, analyze the data and draw contingent, ignoring the covariate. Covariate means ignore all the values of X. So if you ignore all the values of X, what will be left there is to be a CRD problem. So I'm simply saying, ignore the covariate X, please find what? SSE and SST. Because SSTO, you already have it. There's no need for you to recalculate it. You have it. SSTO, we'll need it when we do it. So we want to complete that uncover. So here's that data set, guys. I want to take you back to the data set so that you do those calculations. Oh, sorry, it's not before. From there, we discuss what we are testing. In the afternoon, guys, instead of having a tutorial, we'll continue with the chapter so that we conclude this chapter. In the afternoon, we'll conclude with we have to conclude this chapter today. Here's the problem, guys. I'm saying, I hope it's the same problem of the, yeah, it's the same one. Please find the covariate, find the SSE and SST from this problem. Ignore the X values. Someone is saying SST is 140.4.
Yeah, 140.4.
SST, I'm told, is 140.4. SSE is what? You already have SSTO, right? So you just find the difference. What is SSE? We'll need this information, guys, as we continue. You have SSTO, so you cannot fail to find SSE. SSTO, I'm told, is SS2O. Someone said this. SSE is 206. Makwelele? Come and see me,
Sir,
Makwelele, after. Come and see me after class, ne? At 1 if you are free.
okay.
Okay, I sent you an email. I don't know if you saw it.
Uh,
Um,
uh, uh,
yes,
I was just
you can
having
ask.
a question now on this problem.
Yes.
Because I heard you saying ignore the values of x,
Yes,
but from
those are the
our
questions.
example, so are you just what do we call? Because from the question, I don't see anywhere where you are saying that. So I was just checking if that question you are just adding up to make
No,
the
no,
question.
no. I'm not. It's you will need this information. Even if I didn't say ignore the values of x, you will need this from CRD. Remember, this problem is the combination of CRD and simple linear regression. So from CRD, we managed to find what? We managed to find SSTO. We managed to find SSTO, right? So if you
Yes,
can check, these three information is from what? It's from the CRD, right? Now
yes.
we have to move to simple linear regression. We have to find something related to simple linear regression.
Okay.
You understand? So there are different ways to do this thing, but you'll check which method is best, is faster for you. So with me, usually what I usually do, I will start by finding the information for CRD. But what we need is SSTO, SST, SSE. That is the only information that we need from what? From CRD. You know how to do that. So let's move to um, this simple linear regression part. The simple linear regression part, what you'll need is, let me show you. What you'll need is, let's see. And again, guys, whenever you prepare, don't ignore your study guide. It's very, very important. Don't ignore your study guide, guys. It's very, very important. So I'm almost, yeah. Now we have to move to the CRD part. Let me make this one bigger. You have this one, guys. I hope my query is there. Now, where you have this one, this is solved, this is sorted. This is supposed to be R. It's a mistake here. R, R, number of replications. So if you can check now, you have SSTO, you have SSTO. So to find SSTO adjusted, you need the SSTO that you are having, the SSTO now, minus SS regression. SS regression is given by SS regression. Let me write it. SS reg, you know it from first semester, is given by B1 SS XY. You'll correct me if I'm wrong. Is the formula correct? Is the formula correct, guys?
Yes, sir.
So this can
Yes,
also, to
correct.
save time, guys, this is the same as SS XY
Squared.
over SS. I want to move step by step, leader, multiplied by SS XY, right? So the numerator is the same. So you can square the two SS xy squared divided by SSXX. So if you can check now, we move to what? To the simple linear regression part. Can we please find SS regression now? We have the information. We have SSXY. We have SSXX. Can we please find SS regression? Do you want the values? Should I go to the values? No. Do you want that summary? Here's the summary, guys, for those who missed it, or if you joined late. This is the summary that we agreed on. This is the summary that we agreed. So you need that 286.6 and SSXX.
Sir,
So can we, yes?
it's 230.551.
Can you
They
please
can
write it on the
confirm.
chart? Can you please write on the chart so that we confirm your value leadership? Manyama. We'll go back to that. Guys, Manyama gave us a certain value, so can you please confirm if it is correct or not? Can you write it under the chart, Mr. Manyama? We want your value, that value. Who's saving the value, please?
Sir, I made a mistake, sir, on the denominator. I used the SS total.
Yeah, what? Give us the right thing. It's fine. They didn't say anything, so you still have a chance to give us the right thing.
Three 051 0305.13.
305.13. Guys, here's the value from Mr. Manyama. 305.13. Guys, you are quiet. I don't know if you are having issues with network or what. You are quiet. It's a suggestion from leadership Manyama that the value is 305.13. Yes.
That's correct.
It's correct.
It's correct. Okay. So we have that. The last thing that we need to calculate from there will be almost done with our problem is to find, check the difference, guys. This one, the one that we are finding now, you will need it to find SST adjusted. The one that I'm about to write now, you will need it to find SSE adjusted. Let me repeat. SS reg, you need it to find what? SSTO adjusted, because it will be SSTO minus ST S reg SS reg. And now, using the same idea, can you please find SS reg star? SS reg star will be given by, let me change this. So that information that you gave me at the beginning of the lecture is very, very important. That summary, those values are very, very important now. So SS reg star, oh, I don't want to remove everything. SS reg star is given by, so now we need this one, SS reg, but now with a star. It's equal to, it's the same, it's equal to B star now. This one is having a star. It's different from the one that we just used now. At EXY. EXY, which is the same as what, guys? Can someone extend this formula? How can we write this formula better than the what we did now? It's the same as what?
EXY squared over SSXX.
Thank you. EXY squared divided by EXX, right?
No, divided by SSXX.
Can't be X. We are moving to E. Everything is about E, not X. The one with a star, it goes with the E's. Remember, we have SS and we have the E, right? EXY, EYY, EXX. You remember, my brother? So now we know,
Yeah,
as long as I put the star, as long as I put the star, we need the EXY, the E
it's a
part.
mistake. It makes sense. I see it.
Yeah. So what is the value? Please, not Manyama this time, a different person. I want everyone to be involved, guys, because this is a new chapter. It needs there's a lot of work. Yes, Mangani? Mangani?
I have 178.014.
Wait. 178 point what?
0.014.
014. Guys, here's the value. Do you agree?
Yes, we agree.
So now we are in a position of calculating or now constructing our what? Constructing our analysis of covariance. So let's move to that ANOVA now and check what is what. Yes. I'm listening, leader. Matato. Can you hear Mr. Matato? Guys, can you hear DM? Leaders, are you there?
No,
Yes,
sir.
sir.
Can you hear him?
No.
You can't hear him.
Okay, thank you. It's fine. Maybe he's having issues with network. So here's our analysis of covariance, guys. Here's our analysis of covariance. We have some of this information. Let's check, guys. So far, this one, why are we having 1 year? Apply first semester knowledge. Why are we having with the degrees of freedom of regression being 1 there? Those who did first semester applied linear
Because we have
regression.
one. Because we have
Yes.
one dependent variable, independent.
Independent variable, isn't it? Too, because we have one independent variable So that one, whenever you're dealing with analysis of covariance, focusing on CRD, it's always 1. It's always 1 there. The treatment, remember this one is about the regression, right? So it's 1 there. You don't have to subtract anything. Or it's what? It goes back to number of parameters minus 1. So we have 2 parameters minus 1 is 1. Treatment, you know that one is t minus 1. And now the last part that, you know, to avoid making mistakes, guys, let's check this. It says, because this is very, very important, guys. SS adjusted is equal to SST adjusted plus SSE adjusted. So for you to find the degrees of freedom of error, you cannot say R minus T minus 2 minus the treatment degrees of freedom minus the regression degrees of freedom. So to find the degrees of freedom of error, you only involve what? You only involve these two for you to find this one. You only involve what? This one and this one, isn't it? This degrees of freedom minus this one. You'll be able to find this one. That is why we say SST adjusted. It's equal to, someone is helping me to write now. Are we going to win this battle, guys? Or is it break? Who's this lady? Ramaila.
No, sir, it's not yet break.
Hey, I thought maybe our members that are trying to tell you that it's break time. You see what this one now is? I don't know what it's doing. Decided to put a red line here. And this behavior is continuing and continuing. I don't know why. Do you have a better explanation, Ramaila?
No, sir. I don't know why.
Okay, it's fine. So let's continue, guys, because I want us, when we go for break, when we come back from break, Mangai. Mangai. Matatu.
Sir, repeat what you're saying. Repeat what you're saying about the DF.
The DF, I said the degrees of freedom of regression is 1,
Second.
right? Mangani, leave the session and try to rejoin. Try to rejoin, Mangani. Leave and try to rejoin because it seems like your network is bad.
You can't hear me, sir?
I can hear you, but you are breaking. But now I can hear you. Can I continue then?
Yeah, you can continue. I can hear you in my side.
Okay. I said the degrees of freedom of regression. You know why it is 1, right?
Yes.
And the degrees of freedom of treatment, you understand the idea of T minus 1. We discussed it from simple linear regression, right? First semester. Oh, sorry, from CRD at the beginning, chapter 2. Now, avoid this one. If don't use this one, otherwise you'll make a serious problem. This formula, the best way is to first find the degrees of freedom of total. First find the degrees of freedom of total by using RT minus 2. From there, the degrees of freedom of error, it will be what?
Using what?
RT minus T minus 1. Can someone summarize this? The degrees of freedom of total is RT minus 2. So when you want to find the degrees of freedom of error, I think we must say are degrees of freedom of total, which is this one, minus degrees of freedom of treatment. And let's try to find that. But my advice will be just use the substitution rule. Because if you want to crack your mind, how do we find the degrees of freedom of total? You want to write the formula down, you'll end up confusing yourself. So please just use the substitution rule. So before we go for break, Mangan is still trying to reconnect. As I said that she's having issues with network, she denied, but I noticed that she's having issues with network. So now after break, guys.
I'm back, sir.
Yes, that we'll communicate. We'll talk, my sister, when it's almost break. I want to give these guys a task now, and then you can ask your question after that. So SS reg star, we have this one. We already calculated this one, right? With it. We have this one, SS reg. We calculated that one. We're left with what? We're left with only these three. The other ones is what? This one, remember, we corrected it last week. We corrected this information last week. I don't think we're going to fight because of this. We corrected that last week. So you must first find SS reg. This is the order, guys, so that you win. First find SS reg star. That one you have it. Now you move to what? You move to SST adjusted. You move to this one, which is given by you see here. Let me show you. So this information is from the guide, guys. Here's the formula. So we're saying SSTO adjusted is equal to SSTO minus SS reg. You know what is your SS reg? SSTO adjusted is equal to SSTO minus SS reg. And then SSE adjusted is equal to SSE minus SSE reg star. Do you see it, guys? So you must find the two after break week so that we can do the hypothesis. So what you must give me after break, oh sorry, let me also remove this. After break, I know my Eli is almost break time. Give me 1 minute. After break, guys, please give me the value. Use the value using this is the formula that we can use to find SSTO adjusted, and to find SSE adjusted is here's the formula. The last one, SST adjusted is given by this formula here. SST adjusted is given by that formula there. So this is the part that I need to, after break, give me the three. Let me see if, yeah. After break, give me these three. You have the summary of all these things. Give me this one, SSE adjusted. And to find SST adjusted is the difference between SSTO adjusted and SSE adjusted. Thank you. Makubele, Sacramento?
Sir.
Is it Sacramento?
Sir, it's Manyama.
Manyama. I wanted to use the order because Sacramento's hand was up first. So can I first go with Sacramento and then I'll come back to you, Mr. Manyama?
Okay, sir.
Provided it's still here. Sacramento, your hand was up. Sacramento?
Sir, sir, it's Manga here. It's messing with my PC. I want to ask you something.
Okay.
Sir.
Okay. Mr. Manga.
the reason from the degrees of errors of the total, the reason why subtracting by 2, is it because we have two variables, x and y?
One of the reasons is because we combine two models. There are a lot of
Okay.
reasons behind that.
Okay, thank you.
Yes. So don't make a mistake and less one, you must less two. Matato, from there, leadership, Ramaila is not break. It's not break time.
Sir,
Yes.
yeah, break. Can we continue after break?
Okay. Can I get so it's break, guys? Can you please continue after break? Matato, your hand has been up for some time now. What is happening?
So I wanted to know about SSE. Is it equivalent to EYY?
Is it equivalent to? Oh, because you got the same value, ne?
Yeah.
Yeah, I'm not sure. I'm not sure. I'll look at that one. I'm not sure. I never checked it. You said what?
EYY.
EYY is it the same as SSE?
SSE.
Let's check the formula. The formula can guide us, right? The formula can guide us. But I'll check it. I think maybe after break, maybe I'll be having the answer for that. Please allow me, give me time to check that one, leadership. Is it fine?
Okay.
Yeah, I'll check it for you from there.
Sir, go to the ANOVA.
Leadership manga. You have the ANOVA with you. It's break, right? It's break.
Yes,
manga.
Yeah, I want to see something. I don't want to ask.
Oh, please. I'm just going there to the ANOVA, and I'm not going to say anything. That is the agreement.
Yeah, we don't want to ask anything. We want to see something there. Sir, and please don't forget to post this.
Post what? This is your study guide, chapter 7.
Not this one. There is a note that you promised to post.
I think that one we should discuss it after break, right? Because now you're going to take you want attention, you get attention from people who are on break now. So please let's break and then we'll discuss that after the break. We'll come back at 10 past 12.
Can you go back to the last slide? Mr. Malek.
You said it's break. It's no longer break.
We want to write, go back to that last slide.
Sir. Sir. Yeah. Sir. Sir.
Musibodi?
Sir.
Yes, it seems like you said I must come back.
Yes, I've been calling you.
Oh, sorry for that. I was outside. So,
Yeah,
Mangali, what were you saying?
Me.
Yes, you wanted to say something, and I said, "Oh, you wanted to check something from the ANOVA table, not a it was not a question."
Oh, that one I said you should post the notes.
Which notes are you talking about, Mangali?
The,
For which
the
chapter?
one you promised to post.
For which chapter?
I think it's chapter 2, part 4. I don't know. There's these
Chapter.
notes that are not there in there.
It's about. It's fine. Can you please remain after class?
Sir?
So that you can remind me about the maybe some of the things that we discussed during that session. Can you remain after class, please? Do you mind to remain behind
Alright.
Mangani? Okay, sure.
No.
Leaders, you have, as I've indicated, you have SSTO. Remember when I said you will need the information from CRD. The reason the reason was that you see here we need SSTO from CRD part. We need SSE from the CRD part. So now Let's find the what? Let's find SSTO adjusted. By using this formula, SSTO adjusted minus SS reg adjusted. Nkadimeng, are you here? Mashudu?
Yes.
Please come to my office at 1 if you are
Okay.
free. If you are free,
Okay,
Mashudu.
sir.
If you're not free, we can arrange.
Okay.
What is your SSTO adjusted, guys? SSTO adjusted. Anyone managed to find the value?
$41.27.
40?
41.
41.26, right? The degrees of freedom of SST adjusted?
0.27, sir.
41 point
27.
Christoph 27, not 6. Okay, sorry. And degrees of freedom?
13.
13.
13. Let's go to SSE adjusted. If you don't understand something, guys, please just raise up your hand. SSE adjusted. You have the summary.
27.986.
27 point what, leaders? 978.
986.
986.
Sir,
Can be 99, right? Yes.
what is the value of SSE?
The value of SSE, I'm told, is 260. 206. I
How,
was told it's
sir,
206.
how did they get it?
Christoph, I was given the value long time ago. Let me show you. There was a time where I was given that value. I think it's from here, Christoph. Somewhere here. Remember when we're doing these things? I said leaders can find what? I said SSTO is the same as SSYY, right? I asked the leaders to find SS treatment. What is your SS treatment, guys? SS treatment is given by what?
140.
40.4.
Yeah.
There it is, leadership. When you do the difference, when you want to find the difference, what are you getting, Christopher? Was SSE is true is 206.0, right? What are you getting, Christoph? Well, it seems like you're not agreeing with our value.
I'm getting 305.13 for SS rate.
For SS? No,
Right.
now we're talking about SSE. Because you are saying SS, what is your SSE, Christoph?
41.27.
No, SSE.
Yes.
Is what?
41.27.
But the value that, and then you are but your SSE adjusted is not 28. 27.99, you can say 28, right? But you're not getting this 27.99.
For SSE, no.
SSE adjusted, not SSE. Chris, it's fine.
Yes, I'm getting a negative value.
No, it's fine. Let's do it, Chris. What is your SSE? let's focus on this one. What is your SSE? This one. Can you see the cursor leadership, Chris? What is your SSE? This one.
41.27.
No. It can't be. It can't be 41, my brother. SSE agreed that is 206. 206, Chris. 206.
Okay, what is the value of SS reg?
Can you help us with the value of SS reg, guys? SS reg. I think we still have it here.
It's 178. Fine. I don't know if X.
You don't remember the value, Chris? 178. I remember this value. I was given this value. The one was
178,014.
Chris, check your calculations. I agree with that value. I remember they gave me this value, one something, 178.
Did not for SS reg star.
Sorry?
Is it not for SS reg star?
Yes, that's what we're looking for, right? It's SS reg star.
Yes, I have that one.
So take the difference between the two.
The problem is you see the first equation, SSTO adjusted.
Yes.
Yeah, the problem is the SS reg, not the one with the star.
So your problem is still on 41.27.
Because I got it from that SS reg. I said SSY minus SS reg.
What are you getting?
For SSE, I'm getting 41.27.
My challenge now, leadership, Christopher, why are you saying it's for SSE?
I'm talking about the one without the star.
The one without the star, it goes with SSTO adjusted. The one with a star, it goes with SSE adjusted. What is fine, Chris? What we have to move. What is we are SS reg? Chris, what is your SS reg?
It's 305.13.
305.13. What is your SS total?
346.4.
346.4. Maybe the issue is the decimals there. Or anyone, can someone explain? Maybe I'm the one who's not understanding what Chris is saying. Can someone please help me? What is, yes, Sarah?
So today's having the problem in finding the SSE, not the SSTO adjusted. Is the one below, like the SSE adjusted.
It's failing to find
the SSE from the CRT.
It's failing to find this part. The SSE.
Yes.
Did I get your Chris?
Yeah, she's
Chris?
correct.
So, but what went wrong, Chris? Because this is a CRD problem. You do it the normal way. Let me go to that part. Oh, where's that part? So, Chris, can someone explain what is your SS treatment, Chris? I want us to move now. What is your SS treatment? Yes, Tapelo.
Oh, sir, like I
Yeah.
wanted to know, Uri, how did we get the value of EXY? Like I came in late because of network problems. I wasn't getting the same value of 186.6.
Oh, Candy, you are at the right position to explain this one to leadership, Naredzani. Yeah, Candy will explain how we find that because she was having the same problem. let me finish with Christopher. Christopher, what is your SS3? What is your SS treatment? Chris?
SST adjusted.
In treatment, SST, SS treatment, normal CRD problem. What is your SS treatment?
3, is it not 305,13, say, like SS reg?
No, you don't talk about SS reg now. I'm saying, what is your SS treatment? Makuelele, can you come in?
Yes, I want to, but maybe I think I can explain it better because I had the same problem myself.
Okay, okay.
Because yeah, and it's something that we were talking about when I asked when you were saying something like avoiding the value of X.
Yes.
So SSE is coming from the same formula as when you were saying SSTO is equal to SSYY. So I discovered that SSE is also the same as EYY if you check the formula from the CRD.
Okay.
Yes, so SSE it comes directly from the formula as much as the same as one from the CRD.
Okay. So yes, before I answer the leadership, the other one who need attention with that value. Let me go back to that question. Oh, my laptop is about to go off. I want to go back to the question, right? My laptop is about to, the batteries. Oh. I'm coming. Thank you. Perfect. My laptop was about to go off. So maybe to summarize this thing, guys, I want us to move. Chris,
Yes, sir.
you are, according to my understanding, is you don't know how we got this value. If I understood Tato very well. Am I wrong, Tato?
Yes, he's right.
It's fine. Let me do this. Do you see what I'm doing, Tato?
Yes.
This problem is what now?
You removed the dependent variables. Independent.
Independent variables. We're left with what? We're left with a CRD problem, right?
Yes.
Find these three. Do you understand?
Okay.
That's where we start. When you want to deal with uncover, first find the sum of squares, the same way you used to find them when we're dealing with what? With the when we're dealing with what? When we're dealing with the CRD part. This one is a must for you to have these three because you will need them. You will need these three. So the SSE that you are complaining about now is from a CRD part. The SSTO is when we are not considering the X values. The SST is when we are not considering the X values. Do you understand the X values? Do you understand, Chris? Now, when we bring in the SS reg star, now they need what? The SS reg star and the SS reg without a star. They will need what? They will need that covariate to covariate. So now SS reg star, this one will need the X values. For you to find this, you also need the X values, isn't it? SS reg again For you to find this, you need what? You need the x values, because this is what? This is SS. You see now, we write x. Now it means we need the x here. Squared. Oh, sorry. Well, it's fine. I'll remove this and put it on the other side to save time. Do you understand, Chris? Now here we need what? Now here we need the x values. Now we cannot find SS reg without the x values, and again we cannot find the SS reg star without what? Without the x values. So the x values, they come in when now you want to entertain the part from simple linear. Oh, sorry, this is E. Can we move, Chris? Do you understand now?
Yeah, thanks.
And then there was a question from is it leadership? There's someone who was asking something about this. That person come back. I forgot your surname. Is it Makuelel? Or Makuelel was trying to clarify Christopher?
On what question, sir?
I
Wait,
think it was me.
the one who was. It was okay. Let's go. Oh yes, the leader.
I also asked a question, but I still haven't
Yes.
gotten clarity on it.
Okay. Oh, it's that one, Candy. Oh, the one that I said Candy can explain. I want to check if she understood. Otherwise, I will explain it again. Candy, you remember you had an issue on finding EXY. Candy, are you here?
Yes. Yes.
Yes. So there's a leader who want clarity. I want to check if you understood what I explained. How do we find? I think leadership is about the second part, right? Because the first part is the same as the for ESSXY. So I assume leadership, you failed to find the second part from that formula, isn't it? Leadership? Is the
Yes,
leader
sir.
still here?
Yeah, I think it's the
Okay.
second
Yes,
part.
Candy? Candy?
I'm here.
Yeah,
Okay.
Candy will explain. I used this part to explain. So maybe I can remove this so that whatever Candy will be saying, I'll be writing it down. Candy, over to you.
We have 3 treatments, okay? And then in each treatment there's X and Y. We calculated the sums for each of those X's and Y's. So you're going to say sum of X multiplied by sum of Y, and then you say plus, and then you go to treatment 2. You say sum of X plus sum of Y, and then also go to treatment 3. You say sum of X multiplied by sum of Y, and then you divide it by the replication number of replication.
Leader, do you get this explanation?
Oh yeah, I understood, sir, but I'm still
Yes,
calculating to see if I'll get the same answer.
yeah, you first find the sum for each and every treatment. For you to find that second part, you first find those sums. The sum from the first treatment, you multiply it with the sum of the y part, plus you move to the second treatment, you have the sum of x, the sum of y, you multiply the two before you add with what? With the remaining one, which is treatment 3. So is this the sum from this treatment, from the values of
Oh
what?
yeah, you're right,
You
sir. Like
understand?
now I'm getting 186.6.
Thank you very much, leadership.
No, thanks.
So now, can we move now? Because we remember we were still explaining, trying to check why is Christopher not getting it. So Chris, now you agree with our one 27.99.
Yes, sir.
Guys, you see, the time that we took explaining to Christopher, it can happen to anyone. As long as you don't understand something, ask. It doesn't matter if we take the whole day explaining to you, as long as at the end of the day you understand. So feel free, guys. If you don't understand what is happening, just raise up your hand. Leaders are here to help you. So the adjusted part now is the difference between the two. The difference between the two, you'll find SST adjusted. You'll find SST adjusted. So what is your SST adjusted? You have 41.27, you have 27.99. Let's construct that and let's do this last part, and then we'll construct that uncover. What is your SST adjusted? The difference, guys.
13.284.
13.2. 13.28. So now we're done, guys. Let's go and construct our ANOVA table. Let's go and construct our uncover. Let's go and construct our uncover. And another thing that you should understand, guys, we can test for two things. We can test for the treatments, and we can test for the what? For the regression equation. Looking at that ANOVA table, we can test for two things there. We can test for the treatment, and we can test for the here it is, guys. We can test for the regression. You see, we have F for regression here, and again we have F for treatment. So we're going to test for two things. So there will be a hypothesis for the treatment, and there will be a hypothesis for the hypothesis for the regression equation. I want to look for a page where we can. So now I want us to come up with that ANOVA table, guys. Let's go and find the ANOVA table, the uncover, sorry. I want to go to the whiteboard now. Let's complete the ANOVA and test now. Let's complete the ANOVA, the uncover. We have source. We have regression. You will complete it again. You complete it. Treatment. You have error. And you have total. Degrees of freedom of the regression, we agreed is one. Is one, right? Degrees of freedom of regression is one. Degrees of freedom of treatment is what? We agreed is two because we have three treatments. Degrees of freedom of total is RT minus 2, which will get what? Will get 13. So can someone give me the degrees of freedom of error based on my explanation? What will be the degrees of freedom of error? What is degrees of freedom of error?
11.
It's 11, right? Please, because the addition of the two must give you what? Must give you 30. So sum of squares, SS reg star, I was told is 178. SS total. This one was told is 41.3, as the error is 28 or 27.99. The treatment adjusted one is 13 point, I think leader said 28. So MS, now you divide, guys. This will still be the same 178. So 13.28 divided by 2 will get 6.6. 64, thank you. This one is 2 point what? 27.99 divided by 11 is what?
2.54.
2.54. Thank you. And then we don't need this one. Now let's move to F. F, you divide the F by what? By the MS, isn't it? MSE adjusted. We divide the F by this value, yeah? So I'm told the first value is 69.97. 69.97. And then for the treatment is what? Guys, 2.6.1. So be careful, guys. When you want to test for regression, your F value will be what? Will be 1 and what? And 11. Because for you to find this 69.97, you said 178 divided by 254. So its degrees of freedom is what? Is 1 and 11. When you want to test for the regression, so you find the value from the table. When you want to test for the treatments, it will be F of what? For you to find this 2.61, you said 6.64 divided by this, so it's 2n. 2 and 11. So you're not going to use what? A common F value. You're going to use two different F values. What do you mean, Mangany? What do you mean when I say we don't? Someone is getting a different value, guys. Someone is saying it's 70.08. I think that one is caused by the rounding off of value. Sorry? You're also getting the same value?
I was saying, yeah.
Yeah, I
it's
think
because
it's
we
the
rounded
rounding
off.
off of values. It's just a rounding off. It's not a big difference. It's because you remember we are rounding off some values. That's why we're having different figures. But it's not a big deal, this one, because if you're having 70, she's having 69, and there was no condition of rounding off, you are safe, unless if I indicated that round off your values to 3 decimals. If you fail to follow that rule, then maybe you can be punished. Otherwise, for this one, I didn't specify the rounding, how many decimals. That's why you're getting different values, but the difference is not that big. It's not a big issue. Yes, Mangani, because you just asked us how do we get our values, but you didn't show us what you are having from a side. What are you having, Mangani?
No, I was still struggling to find the F, but I managed now.
You managed, né? Because you remember, for you to find F is that MS for regression. Always you divide by MSE, isn't it? So your MSE here is what? Is the one that is inside that red box. 2.54. So the issue is the rounding off, guys. So now, so again, guys, so for you to find the 41, you don't have to add what? You don't have to add everything. Isn't it, guys? which means SST adjust. So there is a note from your study guide. Let me show you before we continue this one. There is a note there that let me share the study guide again. So in the afternoon, guys, instead of having a tutorial, we'll move to the pairwise comparison. We'll move to pairwise comparison, which is the last part for chapter 7. From there, we'll be done with the scope for test 1. Test 1 will cover all these 3 chapters. Chapter 1, chapter 2, chapter 3. The ones that we cover together is to be the scope for test 1. Whatever will be taught by Mr. Lvo starting from next week will be part of test 2, not test 1. So whatever you'll be covering with Mr. Lvo is not part of test 1. Makube.
Sir.
Can I Makubele?
Hey, sir, it's manga mo.
Oh, please. Okay. Yes, Mang.
Is this part of the test?
Can I repeat my statement? Sacramento. Listen carefully. Ne?
Yeah, and I know it's part of the test. I guess
How did you know, Makubele? I said everything that I'm going to cover with you, including what I'll be covering in the afternoon, is the scope for test 1. Everything that you're going to cover with me is scope for test 1. When I say chapter 1, chapter 2, chapter 3, don't focus on the guide then. It's fine. Chapter 1, chapter 2, chapter 7. If you want to follow the guide. Chapter 1, chapter 2, and chapter 7. Is it fine like that, Mr. Mang?
7, yes.
7 is the one that we're doing now.
Oh.
Yeah, this is indicated 7.3.1. From your study guide, this is chapter 7. So, I want to share something with you guys before. I don't know what's happening now. Can you still hear me, guys?
Yes. Yes, sir, we can hear you.
Oh, okay, it's fine. It's fine. There's a note here. I want to show you so that you don't make a mistake when you are writing tests. Let's check this one, guys. You see, it was saying SSTO adjusted is equal to SST adjusted plus SSE adjusted. Not what? This is very, very important, guys. Not the sum of everything, isn't it? Not, so this is not correct. SSTO adjusted is not equal to SST adjusted plus SSE adjusted plus SS reg. So please, this is not correct. So when you want to find SSTO adjusted, you just have to add whatever is return adjusted here is related to SSTO adjusted. When you add this one, now you'll get wrong information. Because even now, when you wanted to find the degrees of freedom of error, you didn't use what? You didn't use the degrees of freedom of regression, isn't it? Because it's not part of the thing. So now, we'll be having 2 hypotheses that we have to test. If you want to test for the treatments, you use this hypothesis. So let's test. Let's test for the treatment, guys. What are you saying about the treatments? Let's test for the treatment. What are you saying?
There is no difference. It's not.
You are breaking leadership.
Oh, I was saying, for each note, there is no difference between the treatment.
Okay.
Are we supposed to, like, am I supposed to answer the?
You have the ANOVA table, right, my brother, isn't it? So now I'm
Yeah.
saying use that ANOVA table to test for the treatments. What can you say about the treatments? You are right. H0, mu1 is equal to mu2 is equal to mu3, isn't it? That's what I'm saying. And then H1, at least one of the treatment means differ from the rest, isn't it? Is your alternative hypothesis. Is your F calculated greater than F tabulated? Is your F calculated greater than F tabulated? You have the values, guys. I asked you to, or it's fine. Let me, should I go back to the, go back to the whiteboard.
For which one, sir?
I'm saying test for the treatment.
Treatment.
Yes.
F
So
calculated.
it means you must go and look for the value from the table, F table, compare with the one from that uncover, and make a ruling, isn't it?
Yeah. Are we using 0.05 for alpha?
Yes, 5%, please.
Okay.
F calculated is less than F tabulated.
What is the decision? What is your decision? Yes,
we fail to
listening.
reject. We fail.
And conclude. And you conclude
that there is no difference between the treatments.
Treatment
means are the same.
Thank you very much. So now you tested the normal way that you used to test, isn't it? But now you try to adjust your treatment and check if it's going to help you to get better results. So what about the what? What about the regression part? Now we're testing for the other one now. The hypothesis that we'll be testing is this one. This is the hypothesis. Those who still recall regression, in words, what can you say about the first one? H0. When you say B1 is equal to 0, what do we mean? Yes, Malepe?
There is no slope.
Raymond?
There's no linear relationship.
There is no linear relationship between
Response variable and the
the
covariate.
response variable and the X values, isn't it? There is no relationship between the dependent variable and the independent variable. In case our independent our independent variable is what? Is the X variable.
Sir,
or the covariate. Yes.
can we continue at the next class? Time is up.
We're supposed to stop what time, Mr. Budi now?
12:50.
12:50.
12:50. 10 minutes to 1.
Oh, okay, it's fine. So in the afternoon, we'll test about the other the treatment, right? From there, we move to pairwise comparison, where we'll be only focusing only on the LSD method. So second session, we'll be talking about pairwise comparison, and then we focus only on the LSD method. From there, we'll conclude our chapter. I thank you. Enjoy.